Hello everyone, today we are doing a chemistry crash course focusing on the main points in the chapter of air, carbon cycle and greenhouse gases. In this chapter, you have to memorize there are 78% of nitrogen gas, 21% of oxygen and 0.04% of CO2. Because some of the questions they might ask you to compare what is the difference between air composition in this specific planet versus Earth. How exactly that we managed to identify air composition to know that we have 78% of nitrogen gas or blah blah blah. We got to use this thing called fractional distillation, which you will learn in the next chapter. Okay, so for fractional distillation, we will first start with a round bottom flask. Inside, we will put the mixture of any liquids that you want to use, and while we heat the round bottom flask, the liquid will turn into gases. And a tube where a thermometer at the top, because this thermometer can tell us at what temperature what is coming out from the liquid to become gas. But then the next thing here is the Liebig condenser. You have to take note that this Liebig condenser has one input and output for cold water, because the cold water can reduce the temperature and the gas can condense into liquid. So you must take note the water input and water output, as they will ask in exam as well. So at the end, one by one, each different liquid will come out, mainly because they must have different boiling points so that they will not come out all at once. Okay, for air, the main thing is we'll first pass the air through a fine filter just to remove any unwanted solid particles, and after that, we'll drop the temperature to negative 80 degrees Celsius. At this point, the solid water and carbon dioxide will form and they will be removed. For example, at first when we have 100% of air, using knowledge that you will learn in chapter 4, you can calculate the remaining volume of air, and from there you can calculate how much solid water and CO2 that you have removed. After that, we have to reduce the temperature to negative 200 degrees Celsius, and most of the air already liquefy. And when we go through fractional distillation, the air will come out one by one. We will be able to calculate what is the composition of each compound in air. Okay, so the next one, as we have mentioned before, the next cycle in this chapter is carbon cycle. This carbon cycle starts from plants, and we will go into two different steps. So the first step, when your plants absorb the CO2, mainly for photosynthesis, you must memorize the equation here. CO2 and water will give you glucose and oxygen gas. When human or animal consume the plants, we are eating the glucose, and this glucose will react with oxygen in our body. Through respiration, CO2 and H2O will be given out. Okay, another step is if the plant die, they will form hydrocarbon. Hydrocarbon is technically fossil fuel. So this fossil fuel is what we've been using nowadays. Always remember the main thing. When there's burning involved, oxygen is involved. So fossil fuels with oxygen will get back CO2 and H2O. Whenever we talk about CO2, the very main thing is greenhouse gas. The two main greenhouse gases that you must memorize in this chapter are CO2 and methane CH4. So the amount of CO2 in our atmosphere mainly affected by these two factors, the burning of fossil fuels and deforestation. You have to take note, burning of fossil fuels injects CO2 in our atmosphere. While for deforestation, we know that plants are used to take in CO2. However, since deforestation happened, there are less plants, less trees, and the intake of CO2 will reduce, and resulting in a net increase in CO2 in our atmosphere. As for methane gas, you must always remember it comes from the waste gas from digestion and also from decomposition of vegetation. So what exactly is greenhouse gas? Usually energy from the sun, when it reaches the earth, some of the radiation is absorbed. So for example, when 100% of energy coming from sun, and after they reach earth, we'll see maybe 50% is absorbed by the earth and 50% is reflected into the space. However, if there's a presence of greenhouse gas, they will block this heat. So maybe these greenhouse gases will absorb another 20%, which means only 30% of heat is radiated back to the space, while remaining 20% will be re-radiated back to our earth. In this case, the heat absorbed by the earth is a lot more than what is needed, and resulting in global warming. Okay, we have come to the end of this video. If you are interested to understand the main points and even highlights for each of the chapter, feel free to subscribe for more videos. At the same time, you can follow me on this platform to get my free notes and reach out for online lessons. See you soon. Bye bye.